All right, welcome back. Now we've talked. This is for coding challenge number 3. This is the second video that basically breaks down a few other techniques. We've talked about using the gyro. Now let's talk about how to get these sensors working. So, what I would suggest, and I was thinking about, okay, well, what would be the best way to set this up? Well, why don't we work backwards? Let's start by actually intaking a cube. So select one of the cubes and move it into basically into the spot where the intake is going to be located. And that's going to help us so that we can kind of get a sense of what it's like to detect one of these cubes. And we're going to comment out the turn to function for now. So it's just going to stop, it's going to land, it's just going to fall, and that's all. It's not going to do anything right now, just land like that. And then what we're going to do is we're going to make a new function called intake. And that intake function is going to not return anything right now. And then it's just going to move forward. So it's going to, I'll even add a description here. Function causes the robot to move forward until it is at the correct distance from a cube. And so that is what we're going to try doing now. So what we do again is we're going to use another loop to move forward an indefinite amount of time until we're at the right distance. So, and we're going to move forward slowly. So what we're going to do is we're going to take that while true, same thing, but in this case, it's actually going to be, we're going to take the sonar, and this is called the sonar cube sensor, the sonar cube sensor. And we're going to go while sonar cube dot distance, and then we have to pass in distance units. Vex, distance units, millimeters is greater than, let's say greater than 20, so 2 centimeters. Then we're going to move forward. And we can take the code that we wrote before and even use that again. So we go right motor.set velocity, left motor.set velocity. This time we're just going to hard code the speed. So we're going to have, or we can actually go int intake speed, or we'll do double equals, and let's say, let's go with 5. And then in here, we'll go here and pass those in. So then I can just tweak it once and it'll change both. It's not going to be accessible outside of the function. It's just a variable for in this function. So you have right motor set velocity, left motor set velocity. In this case, we're spinning both forward, not turning. And then while this is happening, we're just going to actually sleep for 100 milliseconds. That's all we're going to do. And then when it'll naturally break on its own, because as soon as it gets close enough, it'll stop. And then we are going to call the stop function to actually stop the motors. And so now we're going to, instead of using the turn to function, we're going to go intake. It doesn't require any parameters. We're just going to test it out. So let's see how it goes. And let's take a look here at the values. There it goes. It stopped. Now the value here is 14-ish, and we have it set to be greater than 20. So we can take a look and see how much of a gap there is. You could try to get a bit more precise, but I'd say that's pretty good. Let's try running it one more time and check the values of the sonar. So it's coming, and as soon as it passes 20, it stops. So that is perfect. We have our intake working, and we have our turn working. And see how we're kind of building little tools first? That's exactly how functions work. We're not building the whole thing at once. We're just building pieces. So now that I know that the intake works, and I know that the turn works, we need to figure out a way to get to scan for cubes. So, and the thing is, if I take this cube and I put it here, that's going to be a bit of an issue. So, another thing to mention is that although the turn code is good, it's not perfect, and there might be more that you could do. And I'm not going to explain it very much, but you might notice that it doesn't work in every situation. So, for example, if my robot is already at a certain amount and I want to turn it, like maybe you might want a thing that's like turn 90 instead of turn 290, or maybe you want a function that does like if I'm here and I want to turn to I want to turn to the right, this only turns to the left. So how could you design it so it can turn both ways? I don't have time to talk about that. That's a problem that you need to solve. It would require you to check the values before you check the parameters before you start spinning to determine which way to spin, basically. That's just something I forgot to mention in the last video. But let's talk about if we're going to make it spin to scan for cubes. How could we do that? What could be a very simple way to do that? Well, we could do something similar to our spin code, or to our turn code, but this time it's just going to turn until it sees a cube. So what we're going to do is we're going to write it underneath here, and we're going to go, we'll just write a description first. Function turns the robot until it sees a cube. And we'll call this the search function. And what we could do is we could actually have it return a value if we wanted to. That would be kind of interesting. So instead, we'd actually have it return a Boolean. And the search function is simply going to search for a cube by turning, let's turn counterclockwise. So it's the same as what we already have. So what we're going to do is we're going to set our motors to spinning, just like we did before. And we're going to have our search speed as a variable. Oops. We'll call this search speed. And we'll just have it be 5, but we can see if we want it more or less. And so we have a search speed. We have our velocity again. This time it's forward and reverse. Once again, we're going to have a loop while. And then this time we're going to have, we're going to use the cube distance sensor again. We'll just try to use one sensor, not the redundant sensors. While sonarCube.distance is greater than, and let's say the default right now is, and let's actually, you can run this again and see what the sonarCube's value is. Let's see. The value of this wall is 495 millimeters. So what we're going to do is we're going to have it be greater than 100. Or let's say greater than 300. That's going to be our distance. And what we can do is this value could be tweaked later. We could actually call this our, inside of our, we have search speed, we also have double clipping distance, and let's go 300.0. That's going to be the distance that it does not, like after that point, anything bigger than 300 is completely ignored. Ultrasonic cube dot distance is greater than clipping distance, then we keep spinning. So we might have to tweak this to get it working the way we want, but let's take a look. This we're just going to have a sleep in here. Once again, set that to 100. And after this, we return true. That will break out of this, and that will bring this out. And then inside of here, we're going to actually have a if search equals true, intake. So let's try that. So basically what this means is we are going to call the search function, which is here, but we're calling it inside of our condition. Now if it makes more sense, we could also do this. Bool result equals search, and then we could do if result equals true. And if that makes more sense, it's a little bit more of a long form version, but it does the same thing. So basically we're searching at a speed of 5. So we set the velocity, we start turning, then we jump into a loop where we're just waiting until this clipping distance, until we find something that is less than the clipping distance, so less than 300. And we could even do, yeah, we might have to tweak it. Once we do, we return true. What you could do is you could have basically a condition in here that's like, if I've turned for all 360 degrees and nothing has been found, then I return false. And that means that maybe there's no cubes left. So you could do that. But for now, let's just use this. So we have if result equals true, we intake. So it should actually use the intake function that we already wrote, but only after it finds a cube. So let's try it. Let's see what happens. Hopefully there's no errors. Whoa! It looks like it found one. And ha! Done. And that, my friends, is the simplest way to collect a cube as well as to find cubes. You could make this far much more precise by using the redundancy of the second sensor, because it's at a different distance and it's at a different position. You can use this to help you more accurately determine whether what you saw was a cube or a wall. But for the basics of using the sensor, that's all you need. And what we would do next, what would be the next thing? Basically, you'd have to find a way to return this cube to the end zone. And I don't have time to put a video together for that right now. But the basic principle would be that you would use your turn to function, and you would turn the robot to set itself up into a correct angle, and then you can get into the goal zone. But the best thing to do would probably be to align yourself up with this wall or with this wall, depending on which angle you've intaked your cube. So basically you turn, and if you watch, I did include a video of my solution, and if you watch that video, it shows that I back up here, and then I go forward a certain distance, then I turn 90 degrees, and I go in to the zone. So you could do something like that to help you get accurately get into the zone every single time. And that's all. If you have any questions, send me an email or post in the comments below. And don't forget to like and subscribe, I guess. And yeah, that's it. So thanks for watching, and good luck with coding challenge number 3.